Hello and welcome to World Technology. In this video I will show you my 3D printed robot car. I called Prima and we will assemble it together. Thank you for watching and don't forget to subscribe. First we have the chassis of the robot. It is also called the main body and all other components will be mounted on it. On the top we will have the control circuit, and on the bottom we will have the motors and the primary power bank. These slots in the main body are made to pass wires and cables between the bottom and top. The motors on the bottom will be attached to the chassis using two mounts, and each of them has place for two motors. We place the motors in the mount this way: first motor and second motor. These are the conventional 3 to 6 volts DC motors, but with metallic gear and gear ratio of 1:19. Now the motor mounts will be attached to the main body using these 4 screws. Now we can run the motors wires to the top, and we will connect them later to the shield board. We have here the second mount and the other two motors, and will be mounted the same way. But first we have to place the power bank, which will be here in the middle, and it will be attached to the main body using this holder. We don't need the power bank for now, and we can first attach the holder to the body with 4 screws. It's ready, and we can place the power bank here. I have here a 20,000 milliamp hour bank with output current up to 3.2 amperes. This is enough to cover the maximum power consumption of the Raspberry Pi. And now we can attach the second motor's mount, and we will do the same as we did with the first one. Only the outer screws are well tightened, because the other screws will be used to attach another holder on the top. But even the outer screws could be used to attach additional modules on the top, for example, ultrasonic sensor or speaker. Great! We finished with the bottom, and we have here the motors wires will be connected later to the motors controller. We have the motors shafts where we will attach the wheels. And as I said, these screws are fastened. While these are not, since they will be used to attach this holder on the body. It's actually used to hold a secondary power bank, which can be used to power the motors and to attach the control circuits, the Raspberry Pi and the motors controller circuit. It is also possible to use alternative development boards like the Banana Pi. It has the same pinout as the Raspberry Pi, or even use cheaper controller. I use this small computer because I plan to add more modules to the robot, like camera with objects detection, personal assistance, or mobile weather station. Okay, now we can attach the Raspberry Pi using this case. It will be in the top middle of the robot because it should be accessible to all components. The first part is ready and we have now to prepare the shield board with the motor's controllers. I prepared this shield board so that there will be place for 2 motor controllers, 1 gyroscope accelerometer and a fan for the Raspberry Pi. First we have to solder the connector to the Raspberry Pi, and it's a 40 pins 2-row female connector. We need to check that all pins are well soldered and there are no short circuits between the pins. For the motor controllers, I will use the May pin header where we can place the module. The motor driver TB6612 module is used. Since it can control up to 2 motors separately a constant current of 1.2 amperes. The speed of each motor can be varied by changing the input frequency to the driver module input pins. To connect the module, we just have to insert it in the pin header. This technique is similar to the press fit technique used often for connectors. We will do the same with the second driver. Actually, we have 1 driver for the front motors and 1 for the rear motors. And I decided to use this driver since the maximum current consumption of each motor is 400 mA, and there are no need to use a big driver like the L293 with big heatsink. We have also a gyroscope accelerometer. This will help to detect the speed of the robot and its direction. This can be helpful if you cannot see the robot but you have to move it, then at least you know how fast and where it moves. We soldered the pin header and we can now place the module EMP-U6050. It will be interfaced using a 2C interface and it will provide information about acceleration and movement in the 3-axis X, Y and Z. The motor's connectors are also soldered and now we have to solder the USB connector. This is the power connector for the board. Of course, we cannot use the output of the Raspberry Pi to power the motors because they need much more than what it can provide. The shield board is now ready. We soldered the motor drivers, the gyroscope accelerometer, the Raspberry Pi connector, the USB power connector and the motor's wires connectors, and we can also place the fan if needed. We can now connect the shield board to the Raspberry Pi, but make sure first that there are no short circuit on the board, otherwise it will propagate to the Raspberry Pi. The motor's wires can be connected now to the board. We will check later the rotation direction of each motor and switch the wires if necessary. It's time now to attach the wheels. These are the mechanism wheels. They used to give more robustness to the robot since it can rotate in place and it can do side movements easily. Great. The wheels are attached and we can now connect the power supply of the motors and the Raspberry Pi. If 2 power banks are used, then you have to connect the ground of each bank to the other. And I have this connection already on the shield board. The Raspberry Pi is now switched on, and I have already programmed a launcher script so that the Python code for the Wi-Fi communication and motors control can start automatically. You find a separate video where I explain all steps to prepare the Raspberry Pi for the robot. But now we have to test it. I developed an Android application to use smartphone to control the movement of the robot connected to the same Wi-Fi router.